This is a short video of the homework answers for pages 366 and 367. I'm simply going to move my paper up so that you can see the answers to each question, and then I'll go back and provide an explanation for some of them. So number 1 is option 1. Number 2 is choice 3. Number 3, the answer is positive 3/5. Number 4, the answer is choice 3. Number 5, the answer is choice 1. Number 6, choice 4. Number 7, choice 3. I'm sorry, number 8 is choice 3. Number 7, the cosine of alpha is negative 40/41. Now for the explanations, if you need them, continue listening to the video. If not, you're done. You checked your homework answers. For number 1, it says if terminal side of angle theta in standard position passes through the point negative 4,3, what is the numerical value of sine theta? Well, sine we know is that's opposite over hypotenuse. And they give us the point, negative 4,3. You actually plot the point, negative 4,3, in quadrant 2. Draw your right triangle, label your angle theta. Opposite would be the y value, so that would be 3, and the x coordinate is negative 4. Well, the actual length of this is positive 4, but oftentimes I'll actually put the negative there for the side of the triangle so I don't forget about it. We are in quadrant 2 where sine is positive. Sorry. So our answer is definitely either choice 1 or 2. In relation to angle theta, I know that this is a 3, 4, 5 Pythagorean triple. You would have to find the length of the hypotenuse by using the Pythagorean theorem, a squared plus b squared equals c squared. So the hypotenuse is 5. Number 2, we have the point A, negative 512, lies on a circle whose equation is, so this right here is telling us that our radius squared is equal to 169. So the r value, the radius, is 13. Which of the following would represent the cosine of the angle in standard position whose terminal ray passes through the point? So I plotted the point, labeled the sides of the triangle. Negative 512, 13 is the hypotenuse, which is the same as the radius of the circle. And cosine is adjacent over hypotenuse. So adjacent side in relation to theta would be the leg of 5. And the hypotenuse is 13. We are in quadrant 2 where cosine is negative. So our answer is negative 5/13. Number 3. Beta lies in quadrant 4 and the sine of beta is negative 4/5. So I can do one of two things. I can either draw a right triangle in quadrant 4. Opposite over hypotenuse is sine, so in relation to angle beta, the side opposite would be the negative 4, the hypotenuse is 5, so the other leg of my right triangle is 3. Again, that's just because I know Pythagorean triple 3, 4, 5. And we want the cosine, so that's adjacent over hypotenuse, which would be 3/5. Or we can use, this is the Pythagorean identity, right? The Pythagorean identity is cosine squared theta plus sine squared theta equals 1. Substituting, in this case we have the angle beta instead of theta. So substituting our sine value of negative 4/5, squaring that, that's 16/25. Subtracting that from 1, that's 9/25, and then square root each side. So cosine beta equals plus or minus 3/5. We are in quadrant 4, where cosine is positive, so we want the positive 3/5. And then number 4 is similar to number 3. You can either, we are in quadrant 3, so you can either draw your right triangle in quadrant 3. Cosine, that would be adjacent over hypotenuse. So adjacent to angle beta would be 8. Hypotenuse is 17. Use Pythagorean theorem to get the other leg of your right triangle, which would be 15. Again, these actual lengths would be positive 8, positive 15. But so that I don't forget about the sign, the SIGN in the end of my answer, I'll oftentimes put the negative value there if it is negative. So then we want the sine. Sine is opposite over hypotenuse, negative 15/17. Or you could use Pythagorean identity, which was done in number 3. Number 5, same thing. Let's see, I just chose to draw the right triangle in quadrant 3. If the sine value is 4/5, and we are in quadrant 3, so opposite is 4, hypotenuse is 5. This is a 3, 4, 5 triple. So the cosine of our angle alpha in this case is going to be 3/5. We're in quadrant 3 where cosine is negative, so negative 3/5. For number 6, these are all quadrantal angles, right? They're all multiples of 90, right? So this is just probably a nicer picture. That's what I put on the post-it in color, right? So you want to draw just a quick sketch of your unit circle and x and y axis and then the 4 points. And then the cosine of 0 degrees, well, cosine is going to be the x-coordinate. Cosine of 0 degrees is 1. The cosine of 360 degrees, well, that's 1 full rotation, 360. It's the same as the cosine of 0, which is 1. The sine of 90 degrees. 90 degrees up here, the sine value is going to be equal to the y-coordinate, which is 1. And then the sine of 270 degrees, the y-coordinate is negative 1. So that's your answer there. Number 7, let's see, we're in quadrant 2, and the sine is given to us. So again, my usual go-to is to draw a picture, is to actually draw a right triangle in the quadrant. Opposite hypotenuse. So 9, 41, I've got to use Pythagorean theorem to figure out the other leg. The other leg is 40. And we were in quadrant 2 where cosine is negative. So it would be negative 40 over 41. And then for number 8, which of the following could not be the value of sine? Explain how we can tell. Well, the sine of any angle has to be between -1 and +1 inclusive. You couldn't have a sine value that is greater than 1, right? If I went to this back up here, and if this was a 49, which it can't be, right? Because opposite over hypotenuse, the hypotenuse is always the longest side of your right triangle. So the sine and cosine of any angle will always have to be between the values of -1 and +1 inclusive. So that was choice 3 here, option 3. This was equivalent to approximately 1.6, which is greater than 1. All right, I hope that helped. Thank you.